James Hutton FRSE, the 26th of March 1797, was a Scottish geologist, physician, chemical manufacturer, naturalist, and experimental agriculturalist. He originated the theory of uniformitarianism, a fundamental principle of geology, which explains the features of the Earth's crust by means of natural processes over geologic time. Hutton's work established geology as a proper science, and thus he is often referred to as the father of modern geology. Through observation and carefully reasoned geological arguments, Hutton came to believe that the Earth was perpetually being formed. He recognized that the history of the Earth could be determined by understanding how a process such as erosion and sedimentation work in the present day. His theories of geology and geologic time, also called deep time, came to be included in theories which were called Plutonism and uniformitarianism. Some of his writings anticipated the Gaia hypothesis. Early life and career. Hutton was born in Edinburgh on 3 June 1726 as one of 5 children of William Hutton, a merchant who was Edinburgh city treasurer, but who died in 1729 when James was still young. Hutton's mother, Sarah Balfour, insisted on his education at the High School of Edinburgh, where he was particularly interested in mathematics and chemistry. Then when he was 14, he attended the University of Edinburgh as a student of humanity, i.e., classics. He was apprenticed to the lawyer George Chalmers W.S. when he was 17, but took more interest in chemical experiments than legal work. At the age of 18, he became a physician's assistant, and attended lectures in medicine at the University of Edinburgh. After 3 years he went to the University of Paris to continue his studies, taking the degree of Doctor of Medicine at Leiden University in 1749 with a thesis on blood circulation. Around 1747 he had a son by Miss Eddington, and though he gave his child James Smeaton Hutton financial assistance, he had little to do with the boy, who went on to become a post office clerk in London. After his degree, Hutton returned to London. Then in mid-1750 went back to Edinburgh and resumed chemical experiments with close friend James Davy. The work on production of sal ammoniac from soot led to the partnership in a profitable chemical works, manufacturing the crystalline salt which was used for dyeing, metalworking and his smelling salts, and had been available only from natural sources and had to be imported from Egypt. Hutton owned and rented out properties in Edinburgh, employing a factor to manage this business. Farming and geology. Hutton inherited from his father the Berwickshire farms of Slyhouses, a lowland farm which had been in the family since 1713, and the hill farm of Nether Moynonut. In the early 1750s he moved to Slyhouses and set about making improvements, introducing farming practices from other parts of Britain and experimenting with plant and animal husbandry. He recorded his ideas and innovations in an unpublished treatise on the elements of agriculture. This developed his interest in meteorology and geology. In a 1753 letter he wrote that he had become very fond of studying the surface of the earth, and was looking with anxious curiosity into every pit, ditch or bed of a river that fell in his way. Clearing and draining his farm provided ample opportunities. Playfair describes Hutton as having noticed that a vast proportion of the present rocks are composed of materials afforded by the destruction of bodies, animal, vegetable and mineral, of more ancient formation. His theoretical ideas began to come together in 1760. While his farming activities continued, in 1764 he went on a geological tour of the north of Scotland with George Maxwell Clark, ancestor of the famous James Clerk Maxwell. Edinburgh and canal building. In 1768 Hutton returned to Edinburgh, letting his farms to tenants but continuing to take an interest in farm improvements and research which included experiments carried out at Slyhouses. he developed a red dye made from the roots of the madder plant. He had a house built in 1770 at St John's Hill, Edinburgh, overlooking Salisbury Crags. This later became the Balfour family home and, in 1840, the birthplace of the psychiatrist James Crichton Browne. Hutton was one of the most influential participants in the Scottish Enlightenment, and fell in with numerous first-class minds in the sciences including John Playfair, philosopher David Hume and economist Adam Smith. Hutton held no position in Edinburgh University and communicated his scientific findings through the Royal Society of Edinburgh. He was particularly friendly with Joseph Black, and the two of them together with Adam Smith founded the Oyster Club for weekly meetings, with Hutton and Black finding a venue which turned out to have rather disreputable associations. Between 1767 and 1774 Hutton had considerable close involvement with the construction of the Forth and Clyde Canal, making full use of his geological knowledge both as a shareholder and as a member of the Committee of Management, and attended meetings including extended site inspections of all the works. In 1777 he published a pamphlet on considerations on the nature, quality and distinctions of coal and gum, which successfully helped to obtain relief from excise duty on carrying small coal. Later life and death. From 1791 Hutton suffered extreme pain from stones in the bladder and gave up field work to concentrate on finishing his books. A painful operation failed to resolve his illness. He died in Edinburgh and was buried in the vault of Andrew Balfour, opposite the vault of his friend Joseph Black, in the now sealed southwest section of Greyfriars Kirkyard, commonly known as the Covenanters' Prison. Theory of rock formations. Hutton hit on a variety of ideas to explain the rock formations he saw around him, but according to Playfair he was in no haste to publish his theory, for he was one of those who are much more delighted with the contemplation of truth than with the praise of having discovered it. After some 25 years of work, his theory of the Earth, or an investigation of the laws observable in the composition, dissolution, and restoration of land upon the globe, was read to meetings of the Royal Society of Edinburgh in two parts. The first by his friend Joseph Black on the 7th of March 1785, and the second by himself on the 4th of April 1785. Hutton subsequently read an abstract of his dissertation concerning the system of the Earth, its duration and stability to Society meeting on the 4th of July 1785, which he had printed and circulated privately. In it, he outlined his theory as follows: the solid parts of the present land appear in general to have been composed of the productions of the sea, and of other materials similar to those now found upon the shores. Hence we find reason to conclude, first, that the land on which we rest is not simple and original, but that it is a composition, and had been formed by the operation of second causes. Second, that before the present land was made, there had subsisted a world composed of sea and land, in which were tides and currents, with such operations at the bottom of the sea as now take place. And, lastly, that while the present land was forming at the bottom of the ocean, the former land maintained plants and animals. At least the sea was then inhabited by animals, in a similar manner as it is at present. Hence we are led to conclude that the greater part of our land, if not the whole, had been produced by operations natural to this globe, but that in order to make this land a permanent body, resisting the operations of the waters, two things had been required. First, the consolidation of masses formed by collections of loose or incoherent materials. 2. The elevation of those consolidated masses from the bottom of the sea, the place where they were collected, to the stations in which they now remain above the level of the ocean. Search for evidence at Glentilt in the Cairngorm Mountains in the Scottish Highlands in 1785. Hutton found granite penetrating metamorphic schists, in a way which indicated that the granite had been molten at the time. This showed to him that granite formed from cooling of molten rock, not precipitation out of water as others at the time believed, and that the granite must be younger than the schists. He went on to find a similar penetration of volcanic rock through sedimentary rock near the centre of Edinburgh, at Salisbury Crags, adjoining Arthur's Seat. This is now known as Hutton's section. He found other examples in Galloway in 1786, and on the Isle of Arran in 1787. The existence of angular unconformities had been noted by Nicolas Steno and by French geologists including Horace Benedict de Saussure, who interpreted them in terms of Neptunism as primary formations. Hutton wanted to examine such formations himself to see particular marks of the relationship between the rock layers. On the 1787 trip to the Isle of Arran he found his first example of Hutton's unconformity to the north of Newton Point near Loch Ranza, but the limited view meant that the condition of the underlying strata was not clear enough for him, and he incorrectly thought that the strata were conformable at a depth below the exposed outcrop. Later in 1787 Hutton noted what is now known as the Hutton or Great Unconformity at Inchbonny, Jedburgh, in layers of sedimentary rock. As shown in the illustrations to the right, layers of greywacke in the lower layers of the cliff face are tilted almost vertically, and above an intervening layer of conglomerate lie horizontal layers of old red sandstone. He later wrote of how he rejoiced at my good fortune in stumbling upon an object so interesting in the natural history of the earth, and which I had been long looking for in vain. Quote, that year, he found the same sequence in Teviotdale. In the spring of 1788 he set off with John Playfair to the Berwickshire coast and found more examples of the sequence in the valleys of the Tour and Pease-Burns near Coburn's Path. They then took a boat trip from Dunglassburn east along the coast with the geologist Sir James Hall of Dunglass. They found the sequence in the cliff below Street Helens, then just to the east at Siccar Point found what Hutton called a beautiful picture of this junction washed bare by the sea. Playfair later commented about the experience: the mind seemed to grow giddy by looking so far into the abyss of time. Continuing along the coast, they made more discoveries, including sections of the vertical beds showing strong ripple marks, which gave Hutton great satisfaction, as a confirmation of his supposition that these beds had been laid horizontally in water. He also found conglomerate at altitudes that demonstrated the extent of erosion of the strata, and said of this that we never should have dreamed of meeting with what we now perceived. Hutton reasoned that there must have been innumerable cycles, each involving deposition on the seabed, uplift with tilting and erosion, then undersea again for further layers to be deposited, on the belief that this was due to the same geological forces operating in the past as the very slow geological forces seen operating at the present day. The thicknesses of exposed rock layers implied to him enormous stretches of time. Publication. Though Hutton circulated privately a printed version of the abstract of his theory which he read at a meeting of the Royal Society of Edinburgh on the 4th of July 1785, the full account of his theory as read at the 7th of March 1785 and the 4th of April 1785 meetings did not appear in print until 1788. It was titled, Theory of the Earth, or an investigation of the laws observable in the composition, dissolution, and restoration of land upon the globe, and appeared in Transactions of the Royal Society of Edinburgh, Volume I, Part 2, pp. 209-304, Plates I and II, published 1788. He put forward the view that, from what has actually been, we have data for concluding with regard to that which is to happen thereafter. Quote, "This restated the Scottish Enlightenment concept which David Hume had put in 1777 as all inferences from experience suppose that the future will resemble the past, and Charles Lyell memorably rephrased in the 1830s as the present is the key to the past." Hutton's 1788 paper concludes, "The result, therefore, of our present inquiry is, that we find no vestige of a beginning, no prospect of an end." His memorably phrased closing statement has long been celebrated. Following criticism, especially the arguments from Richard Kirwan, who thought Hutton's ideas were atheistic and not logical, Hutton published a 2-volume version of his theory in 1795, consisting of the 1788 version of his theory along with a lot of material drawn from shorter papers Hutton already had to hand on various subjects, such as the origin of granite. It included a review of alternative theories, such as those of Thomas Burnet and Georges Louis Leclerc, Comte de Buffon. The whole was entitled An Investigation of the Principles of Knowledge and of the Progress of Reason, from Sense to Science and Philosophy. When the 3rd volume was completed in 1794, its 2,138 pages prompted Playfair to remark that the great size of the book, and the obscurity which may justly be objected to many parts of it, have probably prevented it from being received as it deserves. Opposing theories. His new theories placed him into opposition with the then popular Neptunist theories of Abraham Gottlob Werner, that all rocks had precipitated out of a single enormous flood. Hutton proposed that the interior of the Earth was hot, and that this heat was the engine which drove the creation of new rock. Land was eroded by air and water and deposited as layers in the sea. Heat then consolidated the sediment into stone, and uplifted it into new lands. This theory was dubbed Plutonist, in contrast to the flood-oriented theory. As well as combating the Neptunists, he also opened up the concept of deep time for scientific purposes, in opposition to catastrophism. Rather than accepting that the Earth was no more than a few thousand years old, he maintained that the Earth must be much older, with a history extending indefinitely into the distant past. His main line of argument was that the tremendous displacements and changes he was seeing did not happen in a short period of time by means of catastrophe, but that processes still happening on the Earth in the present day had caused them. As these processes were very gradual, the Earth needed to be ancient to allow time for the changes. Before long, scientific inquiries provoked by his claims had pushed back the age of the Earth into the millions of years, still too short when compared with the accepted 4.6 billion year age in the 21st century, but a distinct improvement. Acceptance of geological theories. It has been claimed that the prose of Principles of Knowledge was so obscure that it also impeded the acceptance of Hutton's geological theories. Restatements of his geological ideas by John Playfair in 1802 and then Charles Lyell in the 1830s popularized the concept of an infinitely repeating cycle, though Lyell tended to dismiss Hutton's views as giving too much credence to catastrophic changes. Lyell's books had widespread influence, not least on the up-and-coming young geologist Charles Darwin, who read them with enthusiasm during his voyage on the Beagle, and has been described as Lyell's first disciple. In a comment on the arguments of the 1830s, William Whewell coined the term uniformitarianism to describe Lyell's version of the ideas, contrasted with the catastrophism of those who supported the early 19th century concept that geological ages recorded a series of catastrophes, followed by repopulation by a new range of species. Over time there was a convergence in views, but Lyell's description of the development of geological ideas led to wide belief that uniformitarianism had triumphed. Modern geological thought may be described as punctuated uniformitarianism, that is mostly gradual geological and biome changes punctuated by rare but brief catastrophic events that change the Earth and Earth life. Other contributions. Meteorology. It was not merely the Earth to which Hutton directed his attention. He had long studied the changes of the atmosphere. The same volume in which his theory of the Earth appeared contained also a theory of rain. He contended that the amount of moisture which the air can retain in solution increases with temperature, and, therefore, that on the mixture of two masses of air of different temperatures a portion of the moisture must be condensed and appear in visible form. He investigated the available data regarding rainfall and climate in different regions of the globe, and came to the conclusion that the rainfall is regulated by the humidity of the air on the one hand, and mixing of different air currents in the higher atmosphere on the other. Earth as a living entity. The idea that the Earth is alive is found in philosophy and religion, but the first scientific discussion was by James Hutton. In 1785, he stated that the Earth was a superorganism and that its proper study should be physiology. Although his views anticipated the Gaia hypothesis, proposed in the 1960s by scientist James Lovelock, his idea of a living Earth was forgotten in the intense reductionism of the 19th century. Evolution. Hutton also advocated uniformitarianism for living creatures, evolution, in a sense, and even suggested natural selection as a possible mechanism affecting them. If an organized body is not in the situation and circumstances best adapted to its sustenance and propagation, then, in conceiving an indefinite variety among the individuals of that species, we must be assured that, on the one hand, those which depart most from the best adapted constitution will be the most liable to perish, while, on the other hand, those organized bodies, which most approach to the best constitution for the present circumstances, will be best adapted to continue, in preserving themselves and multiplying the individuals of the race. Investigation of the Principles of Knowledge. Volume 2. Hutton gave the example that where dogs survived through swiftness of foot and quickness of sight, the most effective in respect of those necessarily qualities would be the most subject to perish, and that those who employed them in greatest perfection would be those who would remain, to preserve themselves, and to continue the race. Equally, if an acute sense of smell became more necessarily to the sustenance of the animal, the same principle changed the qualities of the animal, and produce a race of well-scented hounds, instead of those who catch the prey by swiftness. The same principle of variation would influence every species of plant, whether growing in a forest or a meadow. He came to his ideas as the result of experiments in plant and animal breeding, some of which he outlined in an unpublished manuscript. The elements of agriculture. He distinguished between heritable variation as the result of breeding, and non-heritable variations caused by environmental differences such as soil and climate, though he saw his principle of variation as explaining the development of varieties. Hutton rejected the idea that evolution might originate species as a romantic fantasy, according to paleoclimatologist Paul Pearson, influenced by deism. Hutton thought the mechanism allowed species to form varieties better adapted to particular conditions and provided evidence of benevolent design. In nature, studies of Charles Darwin's notebooks have shown that Darwin arrived separately at the idea of natural selection which he set out in his 1859 book, On the Origin of Species, but it has been speculated that he may have had some half-forgotten memory from his time as a student in Edinburgh of ideas of selection in nature, as set out by Hutton, and by William Charles Wells and Patrick Matthew, who had both been associated with the city before publishing their ideas on the topic early in the 19th century. Works. 1785. Abstract of a dissertation read in the Royal Society of Edinburgh upon the 7th of March and 4th of April MDCCLXXXV, concerning the system of the Earth, its duration and stability. Edinburgh, 30 pp. At Oxford Digital Library. 1788. The Theory of Rain. Transactions of the Royal Society of Edinburgh, Volume 1, Part 2, pp. 41–86. 1788. Theory of the Earth, or an investigation of the laws observable in the composition, dissolution, and restoration of land upon the globe. Transactions of the Royal Society of Edinburgh, Volume 1, Part 2, pp. 209–304, at Internet Archive. 1792. Dissertations on different subjects in natural philosophy. Edinburgh and Amp, London, Strahan and Amp Cadell, at Google Books. 1794. Observations on Granite. Transactions of the Royal Society of Edinburgh, Volume 3, pp. 77–81. 1794. A dissertation upon the philosophy of light, heat, and fire. Edinburgh, Cadell, Junior, Davies, at Erara. 1794. An investigation of the principles of knowledge and of the progress of reason, from sense to science and philosophy. Edinburgh, Strahan and Amp Cadell, at University of Virginia Library. 1795. Theory of the Earth, with proofs and illustrations. Edinburgh, Creech. 3 vols. at Erara. 1797. Elements of Agriculture. Unpublished manuscript. 1899. Theory of the Earth, with proofs and illustrations. Volume 3, edited by Sir Archibald Geikie. Geological Society, Burlington House, London. At Internet Archive.